What if the planets in our solar system switched places? Think about Jupiter orbiting where Mars is, or Venus drifting out where Neptune should be. How would our familiar neighbors change? Would Earth survive if it traded places with Uranus? Hold on to your curiosity as we unveil the cosmic chaos that would unfold if the planets played a game of musical chairs. The answers might surprise you and shake up everything you know about our celestial family. Ready for the unexpected? Let's find out what happens when the planets swap their spots. Imagine a scenario where Mercury, the smallest and innermost planet of our solar system, trades places with Jupiter, the largest planet located fifth from the Sun. This drastic change would have profound effects on both planets and the entire solar system. Temperature and atmosphere. Currently, Mercury endures extreme temperatures, ranging from -173 degrees Celsius at night to 427 degrees Celsius during the day. Positioned where Jupiter is now, Mercury would experience significantly colder temperatures due to its increased distance from the Sun. This shift could lead to the formation of a thin atmosphere, possibly composed of gases like hydrogen and helium, which are abundant in the outer solar system. Surface and geological activity. The frigid temperatures might cause any volatile substances on Mercury's surface to freeze. The planet's geological activity could change, potentially leading to less surface contraction and fewer tectonic movements. Orbital dynamics. Jupiter, now the closest planet to the Sun, would face intense solar radiation. Its thick atmosphere, composed mostly of hydrogen and helium, could start to dissipate. The heat might strip away the upper layers, exposing the denser core, possibly revealing Jupiter's solid or liquid metallic hydrogen interior. Magnetosphere. Jupiter's powerful magnetosphere, which extends millions of kilometers, would interact more intensely with the solar wind, possibly leading to spectacular auroras. However, the increased radiation might also affect Jupiter's moons, potentially altering their surfaces and atmospheres. Gravitational influence. Jupiter's significant gravitational pull currently stabilizes the orbits of many asteroids and comets in the solar system. Its new position could disrupt the asteroid belt, increasing the likelihood of asteroids entering the inner solar system and posing collision threats to Earth and other planets. Orbital resonance and stability. The planet's positions and gravitational interactions are delicately balanced. Swapping Mercury and Jupiter could destabilize this harmony, leading to unpredictable orbital shifts for other planets. The newfound gravitational dynamics could cause increased comet and asteroid activity, potentially triggering more frequent impacts on Earth and other celestial bodies. Swapping Venus, the second planet from the Sun, with Saturn, the sixth, would lead to remarkable transformations in both planets and have significant implications for the solar system. Temperature and atmosphere. Venus, known for its extreme greenhouse effect and surface temperatures around 467 degrees C, would become significantly cooler if it occupied Saturn's current position. The thick, toxic atmosphere of carbon dioxide and sulfuric acid clouds might freeze, potentially creating a frozen, barren surface. The atmospheric pressure, currently 92 times that of Earth's, would decrease dramatically. Surface and geological activity. The cooling of Venus could halt its volcanic activity. The surface, now covered with volcanic plains and mountains, would become static, and potential ice formations might appear, assuming there are volatiles present. Ring system possibility. In Saturn's position, the reduced solar radiation might allow for the formation of a ring system around Venus, created from any debris captured by its gravity. Temperature and atmosphere. Saturn, currently a gas giant with an atmosphere rich in hydrogen and helium, would experience intense heating near the Sun. The outer layers of its gaseous envelope could evaporate, potentially exposing the dense core. This transformation might make Saturn appear more like a terrestrial planet, albeit with a drastically different composition. Ring system. Saturn's iconic rings, composed of ice and rock, would likely dissipate due to the increased solar radiation. The particles could either vaporize or be pulled into Saturn by its gravity. Moons and gravitational influence. Saturn's moons, like Titan and Enceladus, would undergo severe changes. Titan's thick atmosphere might be stripped away, and Enceladus's subsurface ocean could freeze or evaporate. Saturn's new proximity to the Sun would drastically alter its gravitational influence. potentially destabilizing the orbits of nearby planets and moons. Orbital resonance and stability. The gravitational forces between Venus and Saturn play a crucial role in maintaining the stability of the solar system. Swapping their positions would disrupt these forces, potentially causing unpredictable shifts in the orbits of other planets. This could increase the likelihood of collisions and alter the asteroid belt's configuration. Swapping Earth, the third planet from the Sun, with Uranus, the seventh, would have profound effects on both planets and significantly alter the dynamics of the solar system. Temperature and atmosphere. Earth, now positioned where Uranus is, would experience extremely cold temperatures, averaging around -200 degrees Celsius. The thick atmosphere, which supports life, would likely freeze, leading to a planet covered in ice. Oceans would solidify, and the hydrological cycle would cease. The atmosphere's composition might shift, potentially losing lighter gases like nitrogen and oxygen into space. Geological activity. The extreme cold would drastically reduce geological activity. Tectonic movements and volcanic activity would slow down or stop, as the internal heat generated by Earth's core would be less effective at such a distance from the Sun. Biosphere and life. Life as we know it would be impossible. The extreme cold would eradicate all known forms of life, from microorganisms to complex multicellular organisms. Any potential life would have to be radically different from current Earth life, possibly existing in subsurface environments if they could retain heat. Temperature and atmosphere. Uranus, an ice giant, would face intense solar heating near Earth's current position. The atmosphere, rich in hydrogen, helium, and methane, would undergo dramatic changes. The outer layers might evaporate, and the planet could lose much of its gaseous envelope, potentially revealing a core of water, ammonia, and methane ices. Magnetic field and orientation. Uranus's unique magnetic field, which is tilted dramatically, could interact differently with the solar wind. Its extreme axial tilt, which currently causes extreme seasonal variations, would also lead to unpredictable weather patterns. Ring system and moons. Uranus's faint rings might be affected by the increased solar radiation, causing particles to vaporize or be pulled into the planet. Its moons, including Miranda, Ariel, and Titania, would experience warmer temperatures, potentially altering their surfaces and internal structures. Orbital resonance and stability. Swapping Earth and Uranus would disrupt the current gravitational balances within the solar system. The altered positions could affect the orbits of neighboring planets and the asteroid belt, increasing the likelihood of collisions and altering existing orbital paths. The gravitational influence of a massive ice giant like Uranus in Earth's current position could have unpredictable consequences for other celestial bodies, potentially destabilizing the inner solar system. Swapping Mars, the fourth planet from the Sun, with Neptune, the eighth, would result in dramatic changes to both planets and have far-reaching effects on the solar system. Temperature and atmosphere. Currently a cold desert world with temperatures averaging -60 degrees Celsius, Mars would become even colder at Neptune's distance. The thin atmosphere, mostly carbon dioxide, would likely freeze out, creating an even thicker layer of surface ice. Any existing water ice on Mars would become even more deeply frozen, and the planet would lose any potential for transient liquid water. Surface and geological activity. The already limited geological activity on Mars would decrease further. The extreme cold would inhibit any remaining volcanic or tectonic activity. Dust storms, a common feature on Mars, would cease due to the lack of atmospheric movement in the frigid conditions. Potential for life. Any existing microbial life, hypothesized to exist beneath the surface, would face harsher conditions. The deep freeze would make it nearly impossible for life to survive, pushing any extremophiles beyond their limits. Temperature and atmosphere. Neptune, an ice giant with temperatures around -200 degrees Celsius, would warm significantly in Mars's position. The thick atmosphere, composed of hydrogen, helium, and methane, would undergo major changes. Increased solar radiation would cause the outer layers to expand and possibly escape into space, altering its appearance and composition. Methane clouds would likely disperse, changing Neptune's characteristic blue hue. Magnetic field and weather. Neptune's dynamic weather patterns, including the fastest winds in the solar system, would intensify. The magnetic field, currently tilted and offset from the planet's rotation axis, would interact more intensely with the solar wind, potentially causing spectacular auroras. Ring system and moons. Neptune's faint ring system might become more prominent due to increased solar radiation causing particle dispersion. Its moons, like Triton, would experience warming, potentially leading to surface changes and increased geological activity, including possible cryovolcanism. Orbital resonance and stability. Swapping Mars and Neptune would disrupt the current orbital resonances. Mars, now on the edge of the Kuiper belt, might interact gravitationally with trans-Neptunian objects, potentially redirecting them into the inner solar system. Neptune, closer to the Sun, would exert different gravitational influences on the asteroid belt and nearby planets, increasing the chances of collisions and altering existing orbital paths. Asteroid belt and Kuiper belt. The displacement of Mars could disturb the asteroid belt, leading to a higher probability of asteroid impacts on inner planets. Neptune's new position could influence the distribution of Kuiper belt objects, potentially causing a redistribution of these distant celestial bodies. Swapping Jupiter, the largest planet in the solar system, with Uranus, the seventh planet from the Sun, would result in substantial changes to both planets and significantly impact the entire solar system's dynamics. Temperature and atmosphere. Moving to Uranus's position, Jupiter would experience a significant drop in temperature. The thick atmosphere, primarily composed of hydrogen and helium, would cool, potentially altering its dynamics. The cloud bands and the Great Red Spot, a massive storm, might change in appearance and activity due to reduced solar energy. Magnetosphere. Jupiter's powerful magnetosphere, which extends millions of kilometers, would interact differently with the solar wind at Uranus's distance. This could affect the radiation belts and auroras on Jupiter and its moons. Gravitational influence. Jupiter's gravitational influence currently shapes the asteroid belt and protects the inner planets by capturing or redirecting comets and asteroids. Its new position would alter these dynamics, potentially increasing the number of objects entering the inner solar system, posing a higher collision risk for Earth and other planets. Temperature and atmosphere. In Jupiter's position, Uranus would be subjected to much higher temperatures. The icy giant's atmosphere, rich in hydrogen, helium, and methane, would warm significantly, potentially causing the methane to dissipate and altering its blue-green color. The atmosphere might expand, and weather patterns could become more intense. Magnetic field and orientation. Uranus's magnetic field, which is tilted and offset from its rotation axis, would interact more intensely with the solar wind closer to the Sun, leading to stronger and more frequent auroras. The extreme axial tilt of Uranus would cause dramatic seasonal changes, with one hemisphere facing continuous sunlight for long periods. Ring system and moons. The rings of Uranus could become more prominent due to increased solar radiation, causing particle dispersion. Its moons, such as Miranda, Ariel, and Titania, would warm up, potentially leading to geological and atmospheric changes, including increased tectonic activity and possible atmospheres forming on larger moons. Orbital resonance and stability. The gravitational forces and orbital resonances within the solar system are delicately balanced. Swapping Jupiter and Uranus would disrupt these balances, potentially causing significant changes in the orbits of other planets and the asteroid belt. This could lead to more frequent asteroid impacts and potential destabilization of the inner solar system. Asteroid belt and Kuiper belt. Jupiter currently acts as a protective barrier, influencing the distribution of asteroids. Its removal from this position could destabilize the asteroid belt, leading to more collisions and impacts on inner planets. Uranus, with its weaker gravitational pull, would be less effective in this role, further increasing the risk of asteroid impacts. Swapping Saturn, the sixth planet from the Sun, with Neptune, the eighth, would lead to dramatic changes for both planets and have significant implications for the solar system. Temperature and atmosphere. Saturn, currently a gas giant with temperatures averaging -178 degrees Celsius, would experience much colder conditions at Neptune's distance. The thick atmosphere, primarily composed of hydrogen and helium, would cool further, potentially causing changes in cloud dynamics and banding patterns. The reduced solar energy might diminish the planet's storm activity, including the iconic hexagonal storm at its north pole. Ring system. Saturn's extensive ring system, made of ice and rock, would be affected by the decrease in temperature and solar radiation. The rings might become more stable and less dynamic, with reduced particle movement. The cold temperatures could preserve the ring's structure for a longer period. Moons. Saturn's numerous moons, including Titan and Enceladus, would undergo significant changes. Titan's thick, nitrogen-rich atmosphere could freeze out, drastically altering its surface. Enceladus's subsurface ocean might freeze, reducing or eliminating its famous geysers. Temperature and atmosphere. Neptune, an ice giant with average temperatures around -200 degrees Celsius, would warm considerably in Saturn's position. The increased solar radiation would cause the outer layers of its atmosphere, rich in hydrogen, helium, and methane, to expand and possibly escape into space. This could alter its blue appearance and reduce the intensity of its winds and storms. Magnetic field and weather. Neptune's dynamic weather patterns, including supersonic winds, might become more moderate due to the increased solar heating. The planet's magnetic field, which is unusually tilted and offset, would interact more strongly with the solar wind, potentially leading to enhanced auroras. Ring system and moons. Neptune's faint ring system could become more prominent due to increased solar radiation, causing particles to disperse and reflect more sunlight. Its moons, such as Triton, would experience significant warming, potentially leading to geological activity, surface changes, and the development of thin atmospheres. Orbital resonance and stability. The gravitational forces exerted by Saturn and Neptune play crucial roles in maintaining the stability of the solar system. Swapping their positions would disrupt these balances, potentially causing shifts in the orbits of other planets and the asteroid belt. This could lead to increased collision risks and altered orbital paths for celestial bodies. Asteroid belt and Kuiper belt. Saturn's current position helps stabilize the asteroid belt. Moving it to Neptune's position could destabilize this region, increasing the likelihood of asteroids being ejected into the inner solar system. Neptune's current role in influencing the Kuiper belt would be diminished, potentially altering the distribution and dynamics of distant icy bodies. Swapping Uranus, the seventh planet from the Sun, with Mars, the fourth, would result in profound changes to both planets and have significant implications for the entire solar system. Temperature and atmosphere. Uranus, currently an ice giant with an average temperature of -224 degrees Celsius, would warm significantly in Mars's position. The atmosphere, rich in hydrogen, helium, and methane, would expand due to the increased solar radiation. Methane clouds, responsible for Uranus's blue-green color, might dissipate, potentially changing the planet's appearance. Magnetic field and axial tilt. Uranus has a unique magnetic field, tilted significantly from its rotational axis. The increased solar energy might lead to stronger auroras and more dynamic magnetic interactions with the solar wind. The planet's extreme axial tilt, which causes dramatic seasonal changes, would result in even more pronounced weather patterns. Rings and moons. The increased temperature and radiation would affect Uranus's faint rings, causing them to become more visible as the ice particles reflect more sunlight. Uranus's moons, such as Miranda, Ariel, and Titania, would experience significant warming, potentially leading to geological activity, surface changes, and thin atmospheres forming on larger moons. Temperature and atmosphere. Mars, currently a cold desert with temperatures averaging -60 degrees Celsius, would become an ice-covered planet at Uranus's distance. The thin atmosphere, composed mainly of carbon dioxide, would freeze, creating a thick layer of dry ice on the surface. Any water ice present would become deeply frozen, eliminating any potential for liquid water. Surface and geological activity. The extreme cold would halt any remaining geological activity on Mars. Volcanic and tectonic activity would cease, and dust storms would become non-existent due to the lack of atmospheric movement. Potential for life. Any existing microbial life, hypothesized to exist beneath the Martian surface, would face harsher conditions. The deep freeze would make it nearly impossible for life to survive, pushing any extremophiles beyond their limits. Orbital resonance and stability. The gravitational forces and orbital resonances within the solar system are delicately balanced. Swapping Mars and Uranus would disrupt these balances, potentially causing significant changes in the orbits of other planets and the asteroid belt. This could lead to more frequent asteroid impacts and potential destabilization of the inner solar system. Asteroid belt and Kuiper belt. Mars's current position influences the asteroid belt's stability. Moving it to Uranus's position could destabilize this region, leading to more collisions and impacts on inner planets. Uranus, in Mars's position, would have a weaker gravitational influence on the asteroid belt, altering its dynamics and increasing collision risks. Swapping Neptune, the eighth planet from the Sun, with Venus, the second, would lead to significant changes for both planets and have far-reaching effects on the solar system. Temperature and atmosphere. Neptune, an ice giant with average temperatures around -200 degrees Celsius, would warm drastically in Venus's position. The increased solar radiation would cause the outer layers of Neptune's atmosphere, rich in hydrogen, helium, and methane, to expand and possibly escape into space. This could alter its blue appearance. As the methane responsible for its color might dissipate, the warming might also lead to more dynamic weather patterns and cloud formations. Magnetic field and weather. Neptune's dynamic weather patterns, including supersonic winds and large storms like the Great Dark Spot, would intensify due to increased solar heating. Its magnetic field, which is tilted and offset from its rotation axis, would interact more strongly with the solar wind, leading to enhanced auroras and more pronounced magnetic phenomena. Ring system and moons. Neptune's faint rings might become more prominent due to increased solar radiation, causing particles to disperse and reflect more sunlight. Its moons, such as Triton, would experience significant warming, potentially leading to geological activity, surface changes, and the development of thin atmospheres. Temperature and atmosphere. Venus, currently the hottest planet with surface temperatures around 467 degrees C, would become extremely cold at Neptune's distance. The thick, toxic atmosphere of carbon dioxide and sulfuric acid clouds would freeze, creating a thick layer of ice on the surface. The atmospheric pressure, currently 92 times that of Earth, would decrease dramatically, resulting in a thin, tenuous atmosphere. Surface and geological activity. The cooling of Venus would halt its volcanic activity and tectonic movements. The surface, now covered with volcanic plains and mountains, would become static, and potential ice formations might appear, assuming there are volatiles present. The extreme cold would eliminate the greenhouse effect, making Venus a frozen world. Potential for life. Any possibility of life on Venus, already limited by its extreme conditions, would become even less likely. The freezing temperatures would eradicate any chance of microbial life existing in the planet's clouds or surface. Orbital resonance and stability. The gravitational forces and orbital resonances within the solar system are delicately balanced. Swapping Neptune and Venus would disrupt these balances, potentially causing significant changes in the orbits of other planets and the asteroid belt. This could lead to more frequent asteroid impacts and potential destabilization of the inner solar system. Asteroid belt and Kuiper belt. Venus's current position influences the asteroid belt's stability. Moving it to Neptune's position could destabilize this region, leading to more collisions and impacts on inner planets. Neptune, in Venus's position, would exert a stronger gravitational influence on the inner solar system, potentially altering the distribution and dynamics of celestial bodies.